alaikum dear students. In this video we will discuss chemical reactions of alkanes in detail. First of all is the chemical reactivity. Alkanes are least reactive among all hydrocarbons. What is the reason behind it? As they consist of carbon to carbon single covalent bonds, these bonds are very stable and strong bonds which requires a lot of energy to break, making alkanes less likely to participate in the chemical reactions. Alkanes undergo three types of chemical reactions. First of all is the combustion, which involves their burning. Second is the cracking, which involves the breakdown of larger chain alkanes. And last one is the substitution, which involves the replacement of hydrogen atoms of alkanes with the other atoms. Now, we will discuss the combustion of alkanes first. What is combustion? Combustion is the burning of a substance in air. It is the most important property of alkanes because they readily burn in air when ignited by a spark or flame. There are two types of combustion, complete and incomplete. Complete combustion takes place in the excess or plenty supply of air, whereas incomplete combustion takes place in the limited supply of air. As alkanes are hydrocarbons, so complete combustion of alkanes produces carbon dioxide and water vapors, whereas incomplete combustion produces carbon monoxide and water vapors. Water vapor is the common product. For complete combustion, carbon dioxide will be formed, and for incomplete combustion, carbon monoxide will be formed. Now we will do some examples. Now, complete combustion of methane. We will construct its balanced chemical equation first. Methane, CH4, it is a gas, plus oxygen, O2, it is also a gas. They combine to form, as it is the complete combustion, so carbon dioxide will be formed. It is a gas along with the water vapors. Now we have to balance this equation. For balancing, remember that always balance the carbon atoms first. As this equation has same number of carbon atoms on both sides, then move towards the hydrogen atoms. For hydrogen atoms, there are 4 hydrogen atoms on the reactant side, whereas 2 hydrogen atoms are present on the product side. In order to balance it, I will add a coefficient of 2 with the water on the product side. Next is oxygen. To balance the oxygen atoms, look for the number of oxygen atoms on the product side. Now, there are total 4 oxygen atoms on the product side, 2 from the oxygen and 2 from the water molecules. So, 4 is an even number. We will write half of it on the reactant side with the oxygen molecule in order to balance it. Now, on the reactant side, there are 4 oxygen atoms when we multiply 2 with the 2. Moving towards the incomplete combustion, CH4 plus oxygen makes carbon monoxide plus water vapors. Again, in this equation, there are same number of carbon atoms on both sides. Then we will look for the hydrogen atoms. As there are 4 hydrogen atoms on the reactant side, there must be 4 hydrogen atoms on the product side. So we will write 2 with the water. Now look for the oxygen on the product side. There are 3 oxygen atoms on the product side. 1 from carbon monoxide and 2 from water. As 3 is an odd number, we will write 3 as it is with the oxygen molecule on the reactant side and multiply rest of the equation with the 2. Now write down the final equation. 2 volume of methane reacts with 3 volume of oxygen, forms 2 volume of carbon monoxide with 4 volume of water vapors. So this is the balanced equation for the incomplete combustion of methane. Now we will discuss these rules for balancing in detail. In order to balance the chemical equations for the combustion reaction, first of all balance the carbon atoms on both sides of the equation. Then hydrogen atoms. Next, look for the number of oxygen atoms on the product side. If there are even number of oxygen atoms on the product side, put the half of that number with the oxygen molecule on the reactant side and equation will be balanced. But in case of odd number of oxygen atoms on the product side, put that number with the oxygen molecule on the reactant side and multiply rest of the equation with the 2. Now we will balance some more equations. For example, for the complete combustion of octane, the formula for octane is C8H18 plus oxygen. For complete combustion, it makes carbon dioxide with water vapors. So, as there are 8 number of carbon atoms on the reactant side, there must be 8 number of carbon atoms on the product side. So, we will write 8 with the carbon dioxide. Now, next we have to balance the hydrogen atoms. There are 18 atoms of hydrogen on the reactant side. There must be 18 hydrogen atoms on the product side as well. So I will write 9 here in order to make the hydrogen atoms 18. Now I will look for the oxygen atoms on the product side. There are total how many atoms of carbon? 8 into 2 makes 16 plus 9 from the water side. 16 plus 9 makes 25 oxygen atoms on the product side, which is a odd number. So the rule is, if there is odd number of oxygen atoms on the product side, write that number with the oxygen molecule on the reactant side and multiply rest of the equation with the 2. Now I will write down the final balanced equation. It will become 2C8H18 plus 25 molecules of oxygen. They form 16 volumes of carbon dioxide with 2 into 9, 18 volumes of water vapors. So this is the balanced chemical equation for the complete combustion of octane. Now we will write down the equation for the incomplete combustion of octane. C8H18 plus oxygen makes carbon monoxide plus water vapors. In order to balance the carbon atoms, there must be same number of carbon atoms on both sides. So I will write 8 here with the carbon monoxide. Now next is the turn of hydrogen atoms. There are 18 hydrogen atoms on the reactant side. So there must be 18 hydrogen atoms on the product side. Now we will look for the oxygen atoms on the product side. How many oxygen atoms are present? 8 plus 9 is 17. 17 is again odd number. So according to the rule, it will be written as such with the oxygen molecule on the reactant side and multiply rest of the equation with the 2. Now write down the final balanced equation. It becomes 2C8H18 plus 17O2 makes 16 carbon monoxide plus 2 into 9, 18 H2O. So this is the balanced equation for the incomplete combustion of octane. Now pause the video and practice the rules for balancing by writing the equations for the first 5 members of the alkanes homologous series. Write down the equations for the both type of combustion. And please learners, it is very important to note down here that there are many students who have all the concepts of chemistry. They have a very strong grip on the chemistry, but they are unable to write down the equations well. This is only because they don't practice them by writing them down. Please always practice the equations by writing them. At least write down the equations five times when you practice or revise the concepts. Please write down the equations 5 times. Okay. Now, next chemical reactions that alkanes shows involve the cracking. As the name shows that cracking involves the breakdown of a substance. Cracking means to break down. So what is its definition? It is the breakdown of longer chain alkanes into smaller alkanes and alkenes. And what are the conditions? In the absence of air, at high temperature, in the presence of a catalyst. Now there are two types of cracking, thermal and catalytic cracking. Thermal cracking takes place at a very high temperature, and the temperature is almost 1000 degrees Celsius. In order to speed up the chemical reaction or to make the reaction to take place at lower temperature, catalysts are used. So this type of cracking is known as catalytic cracking. The conditions for the catalytic cracking are: temperature is lowered down to 400 to 600 degrees Celsius, and the catalyst used are aluminium aluminium oxide and silicon 4 oxide, sand, SiO2. Now, there are two options for the products during the cracking. Longer chain alkane is cracked down. There are two options. First option is that smaller alkane is formed with the alkene. And the second option is that the alkene is formed with the evolution of hydrogen gas. Now we will do some of the examples for the cracking. For example, we take the example of octane. C8H18 we can write down any fraction of the carbon atoms, like I want to form alkane with the alkene. I will break down it into two equal portions, like 4 carbon atoms I will take in the alkane and the 4 carbon atoms will go in the alkene side. Now using the general formula, we will derive the formula for the alkane with 4 carbon atoms. The 4 carbon atoms of alkane will be C4, H2 into 4 is 8, 8 plus 2 is 10. And for alkene, the general formula is CnH2n. So its formula will be C4 and H will be 2 into 4 is 8. Now there are same number of carbon and hydrogen atoms on both sides of the equation. Let's do some question for the cracking. First question is hexadecane, its formula is C16H34 undergoes cracking. A mixture of butane and butene is formed only as the product. Construct the balanced equation for this reaction. Now, according to the equation, butane and butene are formed as the products. So, we will crack down the hexadecane C16H34 into butane and butene. So C16H34, butane is alkane with 4 carbon atoms, C4H10. And for butene, the general formula for alkenes is CnH2n. The molecular formula for butene will be C4H2 into 4 will be 8. Now we have to balance this equation. For balancing, what we will do is we will put 3 with the butene in order to balance the equation. Now there are same number of carbon and hydrogen atoms on both sides of the equation. Next, there is another question. Octane undergoes cracking. 2 volumes of ethene and 1 volume of butene along with 1 more products are formed in the cracking reaction. Construct the balanced equation for the above reaction. So products are again mentioned here, only 1 product is missing. We have to identify or we have to guess it. First of all, I will write down the rest of the equation. Octane is C8H18. It is making 2 volumes of ethene. 2 volumes of ethene, 1 volume of butene. It means a mixture of alkenes is formed. So if alkene is formed as one of the product in cracking, the other product may be alkane or hydrogen. So we will look for it by writing down the equation. First, C8H18, 2 molecules of ethene will be C2H4 plus butene is C4H8. Now there must be 8 carbon atoms on both sides. Now we will see that on the product side how many carbon atoms are present. There are 2 into 2, 4 plus 4 carbon atoms on the product side. This means carbon atoms are balanced. Now look for the hydrogen atoms. 2 into 4, 8 plus 8 hydrogen atoms in butene. This makes 16 hydrogen atoms. This means there must be 2 hydrogen atoms on the product side. So I will write hydrogen molecule here in order to balance the equation. This means that the missing product is the hydrogen gas. Now, importance of cracking. First is hydrogen gas is prepared. During cracking reactions, hydrogen gas is produced as the byproduct. But hydrogen is a very important raw material in the manufacturing of industrial scale preparation of ammonia. In the Haber's process, it is used as a raw material for the manufacturing of ammonia gas. Second importance is alkenes are prepared. Alkenes are used as raw material for the making of plastics. So this is it. Also one of the very important use. Last and the most important use of cracking is that larger, less useful petroleum fractions are converted to smaller, more useful fractions in order to meet the demand of fuel with the supply. This means that larger, less useful petroleum fractions, for example, bitumen. Bitumen consists of long chain of carbon atoms and they are very low in demand. So bitumen is cracked down into smaller useful fractions in order to meet the demand of fuel for the smaller alkanes. Now, next are the substitution reactions. Okay, as in alkanes, you know that all the valence electrons of each carbon atom is involved in the formation of 4 single covalent bonds. All carbon atoms are involved in the formation of 4 single covalent bonds here. And these are the maximum number of bonds that a carbon atom can make. So this means that no new atom can be added in the alkane. However, already present hydrogen atoms can be substituted or replaced with some other atoms. So these type of reactions are known as substitution reactions. What is the definition of substitution reaction? Reaction in which hydrogen atoms of an alkane are substituted with other atoms, for example halogens, is known as substitution reaction. What is the condition for the substitution reaction? It takes place in the presence of diffused sunlight. Diffused means not the direct sunlight. This means that substitution reactions are photochemical reactions. They are photochemical reactions. What are photochemical reactions? Reactions that takes place in the presence of light. They are known as photochemical reactions. In bright sunlight, the reaction is highly explosive, whereas in dark there is no reaction. However, in diffused sunlight, the hydrogen atoms of the alkanes are replaced with some other atoms. Replacement of hydrogen atoms takes place and a variety of products are formed. Substitution reactions continues till all the hydrogen atoms in an alkane is substituted with the other atoms. Let's do the halogenation of methane. So, I will first draw the displayed formula of methane. CH4 plus Cl2. Chlorine will take the place of hydrogen atom and hydrogen atom will take the place of chlorine here. The products are CH3 Cl with hydrogen chloride gas. The name of the main product, which is also known as the organic product, is, as only one chlorine atom is substituted, so is here, so the name will be monochloromethane. Now this product will use as a reactant in the next step. CH3Cl plus Cl2. Chlorine will take the place of hydrogen and hydrogen will take place the chlorine place. So the product will be CH2Cl2 with the evolution of hydrogen chloride gas. So as in the product two chlorine atoms are present, the name of the product will be dichloromethane. Next, dichloromethane will be used as the reactant. Chlorine will take the place of hydrogen and hydrogen will take the place of chlorine. The product will be CCl3 and CH here with hydrogen chloride gas. Now the name of the product will be trichloromethane. Its common name is chloroform and it is used as general anesthesia. In the last step, chloroform will be used as the reactant and the last hydrogen atom of methane will be substituted with the chlorine atom. the product form will be CCl4. Now there will be no hydrogen atom in this product with hydrogen chloride gas. The name of the product is tetrachloromethane. The common name of this product is carbon tetrachloride. Carbon tetrachloride, and it is used as a solvent for dry cleaning. It is used as a solvent for dry cleaning. Now we will do some more examples. In exams the questions come directly. For example, the question comes like this: construct the balanced equation when 1 volume of methane reacts with 2 volumes of chlorine. Now what will I do is 1 volume of methane, this means CH4 plus, it will react with 2 volume of chlorine to form. You know that in this reaction one will be the organic product and the other will be the byproduct, that is hydrogen chloride gas. For this, now there are total 4 chlorine atoms in 2 chlorine molecules. Out of 4 chlorine atoms, 2 chlorine atom will go in the main product and 2 chlorine atom will go in the byproduct. So what will I do is, if 2 chlorine atom will go in the main product, this means that 2 hydrogen atoms will be kicked out. CH2 and Cl2 will be formed, CH2Cl2 plus the 2 hydrogen atoms that are kicked out of the methane, they combine with the 2 chlorine atoms and form 2 volume of hydrogen chloride gas as the byproduct. So this is the balanced chemical equation when 1 volume of methane reacts with 2 volume of chlorine. Let's do another example. Question is, draw the displayed formula of the organic product form when 1 volume of ethane reacts with 3 volumes of chlorine. For this, I will write down the balanced equation first. 1 volume of ethane, ethane is C2H6. It will react with 3 volumes of chlorine. In 3 chlorine molecules, there are total 6 chlorine atoms, out of which 3 will go in the main product and 3 chlorine atom will go in the byproduct. So what will be the product form? Carbon atom will remain the same, hydrogen atoms will be changed, as 3 chlorine atom will go in the main product, so 3 hydrogen atoms will be kicked out of the methane. So the remaining 3 hydrogen atom will be written down and 3 chlorine atoms that are substituted here. Plus, how many volumes of hydrogen chloride gas will be formed? As there are 3 hydrogen atoms and 3 chlorine atoms, they combine to form 3 volumes of hydrogen chloride gas. So this is the balanced equation when 1 volume of ethane reacts with 3 volume of chlorine. But in the question, it is asked to draw the displayed formula of the organic product form. So this is the organic product. We will draw its structure. There are 2 carbon atoms, 3 hydrogen atoms, 1, 2 and 3, and 3 chlorine atoms. So this is the displayed formula of the product formed. Next, there is another question. The question is, the substance X, Y and Z shown in the following reactions are alkanes. Okay, now these 3 reactions are given and what we have to do is, we have to find X, Y and Z. we have to draw their displayed formula. Okay, for this we will look at the product. On the product there is only one chlorine atom present in the main product. This means only one hydrogen atom is substituted. So the displayed formula for the alkane will be CH3 CH2, and in place of chlorine hydrogen atom will be written here. So this is the formula, displayed formula for the X. Now next is only one chlorine atom is present with the middle carbon. This means that we will just write down hydrogen with the middle carbon instead of chlorine, but we have to draw its displayed structure, so all hydrogen atoms should be shown. CH3. In place of chlorine I will write hydrogen to get the alkane, and CH3 will be written as such. Next, so this is the structural formula or full displayed structural formula for the alkane Y. Now what is alkane? Alkane Z. On the product side there are two chlorine atoms present with two different carbon atoms. So this means that two hydrogen atoms are substituted. In place of chlorine we will write two hydrogen atoms here. So what will be this displayed structure for the alkane? I will start from the left side. CH3. Now this is the second carbon, C. In place of this chlorine I will write, in the place of this chlorine I will write hydrogen, CH. Next is third carbon. Again in place of chlorine hydrogen will be written, and the last carbon atom is attached with the three hydrogens. So this is the displayed formula for the alkane Z. In such type of question, just replace chlorine with the hydrogen atoms to get the alkane from which the product is formed. So this is all about the chemical reactions. Now we will summarize all the chemical reactions of alkanes. First, we did the combustion reactions. In combustion, alkanes are burnt either in the limited supply of air, which is known as incomplete combustion, and the products formed are carbon monoxide with the water vapors. Whereas if burning takes place in the excess supply of air, complete combustion takes place and carbon dioxide with the water vapors are formed as the product. Next chemical reaction is cracking. In cracking, larger chain alkanes are broken down at a temperature of 400 to 600 degrees Celsius in the presence of aluminium oxide and silicon 4 oxide as the catalyst in the absence of air, and as a result alkane with alkene is formed, or alkene with the hydrogen as a byproduct is formed. Last reaction was substitution reaction. Substitution reaction takes place in the presence of diffused sunlight. It is a photochemical reaction, and as a result of this, haloalkane is formed with the evolution of hydrogen chloride gas. Haloalkane is the main product and hydrogen chloride is the byproduct in this reaction. So this is all about the chemical reactions of alkanes. I hope you find this video helpful. So stay happy and Allah Hafiz.